So I have one good, and I want to find out the elasticity of demand. So the elasticity of the output versus the price. It's called price elasticity of demand. Demand for X. Okay, so what is it? It is, I want to find out the percentage, what is the percentage change in P? Okay, so let's say that we'll do everything with respect to, I can do it with respect to the price or respect to the quantity. So let's say that my demand is P of X, and this is the inverse demand, okay? Oh, but then let's talk, and I can look on X of P. You know what, let me do the X of P. So the X of P, I change the price by a little bit. So I have to look on X, P plus delta P, minus X of P. In percentage terms, I have to divide by X of P. This is, if you want, multiplied by 100. So this will be the percentage change in X due to delta P change in price. But now I want to divide that, I want to see per unit of price. So the change is actually delta P. That is the change. In terms of percentage, I have to divide by P times 100. I start with P. Let's do, suppose that this is P now and this is X, it will be easier. Let's say that I'm here P and this is P plus delta P, and this is the demand. So I'm looking on what is this is X of P. This is X of P plus delta P. And the change in, so this is the change in X versus the change in the price. However, I'm not interested, this will be the slope of the demand. I'm interested in percentage terms. So I started with this point, and by the way, if I start at this point, it will be completely different. So therefore, I want to, what is in percentage term, is the delta, let's say delta P divided by P. Let's say that P was 10, and I increase it to 11. So I increase it by 10%. The increase is from 10 to 11, 1, divide by 10. And multiply by 100, but as you can see, the 100 is cancelled out. The same here, I ask, okay, what happened? So I reduce my demand due to increase in price, I reduce the demand from that to that, so this is the change. But that's the change, the original one was X, and now it's X of P, but now it's X different X, of P plus delta P. So this is only that part, only this part, is delta P, delta X. So actually what I have is actually, this is delta X over X divided by delta P over P. So this I can write it as delta X over delta P times P over X. Now I take when they change, when delta P is very small. So I want it by 1%, but in percentage, but when I make the change to be extremely small, delta P. Then this is actually how X, my demand, okay, how my demand changes with P. So this is X prime of P. This is exactly the limits of delta X to delta P when delta P goes to 0 is the derivative of X with respect to P times the P over X. And if I want to get everything with P, then that X is x of p. Is actually, this is x of p. Okay, so it's p and x of p. Because the p and the x related. How p and the x related? This is p, so this is the x of p. So if you like, I should put here p. So p is fixed. I'm talking about specific p, p10. And as you can see, that elasticity varies in general from p to p. Okay? In the case of Cook-Douglas, for instance, where I have that x1 is a over the utility of x1, x2, x1 to the a, x2 to the b. It was a over a plus b, m over p1. So if I want to measure the elasticity of demand of x1 with respect to p1, so first of all I want to find out x1 prime of p. I have to take the derivative. All this is constant. So it's a over a plus b m times minus 1 over p1 squared. This is 1 over p1, it's p1 to the minus 1. When I take the derivative, it is minus p1 to the minus 2 minus 1 over p1 squared. So, by the way, always, because this is negative, the elasticity of demand is always negative. Okay, so I'm getting this one, and then I have to multiply, so the elasticity of x1 to p1 is what? The derivative times p, so it's negative am over a plus b p1 squared, this is this part, times p, over x1, over x, or x1, here it's x, but over x1. So what is x1 of p? This over a plus b m over p1. So actually we get the constant elasticity, but first let's do it slowly. This goes with this. This goes with this. Now I have p1 squared and I multiply by 1 over p1. I'm getting this and this goes. And here I have p1 and p1. And I'm getting a plus b over a plus b minus 1. Which means that in case of the Cook-Douglas function, if you change the price by 1%, if you increase, if you like, the price by 1%, you decrease the quantity demanded by 1%. The linear case is completely different. Now, what they are doing here in the next slides, so I may use it, but let's go down to the next slides. And before moving to the next slide, I say that the elasticity really depends on the price that you start from. But in Cook-Douglas, it so happened that it does not depend on the price. The price elasticity of demand is minus 1 no matter what is the price. This is typically not the case. I mean, let's say we're going to talk about linear demand, it would not be the case. Now, let me say, the slides that will come back to it have to do with, sometimes I don't know to the demand everywhere, but I know the demand at some price, and let's say I know the demand in a price close to it. And then the question, I want some average of elasticity, simply because I don't know the demand. If I don't know the demand function, how can I take derivatives and do all this? So in that case, we use some points where we know, and I'll come back to that. That is actually an average price elasticity of demand. But I want to, I'll come back to that in a second, or not in a second. You see, here it is what we have. And now suppose, okay, here is an example. So this is the price elasticity of demand. it's the derivative of xi with respect to its own price times the price over the xi. And this is the price that I start. This is the xi at this price. And this is the derivative of xi at this price. Everything starts from this. This is fixed. We fix that. And we take the derivative of the demand function, plug in the price, and multiply and divide by xi, which is the demand at the price. Good. So example, suppose pi equals a minus bxi. This is, by the way, the inverse demand, okay? If you like. But I can write xy, that's the demand, and this is the inverse demand. xi is a function of a function of pi. That's a demand. Given pi, how much I want to demand. Okay. So from here, what do? I take the pi here, it's a minus pi, and I take the pxi out, divide by b, I'm getting this. What is the derivative with respect to pi? Negative 1 divided by b. Therefore, what is the price elasticity of demand for linear case? It is pi over a, let's do it slowly. So I have this, but first of all I have to take the pi. I take the pi. Now I have to take the xi at pi. So I look at xi at pi. So it's a minus pi divided by b. I'm writing it here. Times the derivative, which is this. So the b goes up and divide by this b, and I'm getting that. Pi minus, always minus, pi over a minus pi. And as you can see, it is an elasticity of demand very dependent on, not like in the Douglas case, it's very dependent on what price you do the exercise. Maybe the price now is $10 per unit. You want to know now, if I change a little bit, the 1% increase in price, how many percentage it will decrease my quantity? So this is it, and let's work it out. So remember, this is if x, pi, p1, pi equals a minus bxi. So I have many goods, but that's the demand for good I. So from here I'm getting that xi is a minus p is a minus pi divided by p. That's demand. So that's inverse demand. Inverse demand is for a given x, what should be the price such that my demand will be this? And this is demand. Okay, and the elasticity, we saw that of xi, they put star, doesn't matter, of pi is negative, and we have pi over a minus pi. So the slope doesn't matter. You see, the slope doesn't matter. Okay, for all slopes, it's the same. B doesn't matter. Okay, now, let's see. So here is the line. So if it is, we're talking about p equals a minus bxi. So when xi is 0, the pi is a. When pi equals 0, xi is a over b. So this is the line, this is our... Now, what is the elasticity at this point? Put instead of xi, okay, if this is the elasticity with respect to pi, what is the pi here? Okay, the pi here is 0. Correct? This is 0 here. That's the pi. So here, I have to divide 0 by a, it is 0. So the elasticity here is 0. Here the elasticity, you have to divide by a minus a, it's infinite. So you get if pi equals a divided by 0 is infinite. So the elasticity of demand goes from 0 to infinite. At some point it is 1, and it is called unit elasticity of demand. It has some properties, but slowly. I have it here, so I don't need to. So at P equals 0, elasticity, we forget about this, is price equals 0, it is 0. 0 over something, 0. So 0. Now we'll jump here. A minus A, I divide by 0, it's infinite. Okay, let's do the middle point. At the middle point I have, so if P is half of A, which is the middle point of this demand curve, then it will be A over 2, divide by A minus over A over 2, it is minus 1. Okay, that there is minus 1. And if it is A, it's negative infinity. So here it's negative infinity. Okay? I cannot, here you cannot talk about a change in percentage term, because when I change here the price a little bit, I increase the price a little bit by 1%, they from here in this point, so they buy 0. But if I change it, I have to divide it, then I have to multiply, if you like, by, I didn't write it here, but here then, in general the elasticity, I'll come back to that in a few minutes, okay? Let's do it slowly. On price, the price elastic here, this is elastic, if it's from 1 to infinity, everything negative. So this is called elastic. Why? You see that, what happens here? If I change, if I'm at here, namely if the price is A over 2, and I change the price by 1%, I increase the price by 1%, at this point it will increase my quantity by, it will decrease my quantity by 1%. But if I go, let's say I'm here, and if I change the price by 1%, I may increase the price, may decrease the quantity here, but by much more than 1%. Up to goes to infinity. And in this case, okay, if I change at this point, I increase the price a little bit, okay, it says that by 1%, there's almost no change in the quantity, the decrease in quantity, and the elasticity is 0. So no change. In that case, I don't mind if I'm here, price is 0, to increase the price, because it will not decrease or increase negligibly my quantity demanded here. So this is the general formula. And now this is inelastic, because here it's completely inelastic, up to, if you change it by less than 1%, if I increase the price by 1%, and as a result, the decrease in output is less than 1%, then I can say that it is inelastic. If from here onward, if I change the price, increase the price by 1%, and therefore decrease the quantity by more than 1%, then I call it elastic. Very natural. So this is price unit elastic. Okay, unit elastic, 1% versus 1%. So now we take another, so this is the formula. This is the derivative actually. And let's say that I'm talking about a demand function which is just some constant times pi to the a. Okay, so that's how xi depends on pi. A should be negative. Why A should be negative? Otherwise the demand going up with the price, that will be a given good if it's positive. Negative, think of it. Okay. So this one is derivative. The derivative of this is what? A times pi a to the minus 1. Okay? The derivative of xi to d pi, and I think that they missed the k. Okay? And then pi over xi, So the elasticity will be pi over xi. What is xi? kpia times kap minus 1. So here we miss the k. I'll change it for you later on. So k and k goes. Pi times pi to the a minus 1, it's pia, it's cancelled out, and you have, the result is that it's a. Namely, for such demand function, for instance, if you like, and as an example, suppose that xi of p is 1 over p squared, or 4 over p squared. So k is 4, and a is minus 2. In that case, what is the elasticity? Constant. Namely, no matter where are you on the graph, how this looks like, such a demand function obviously look like this, and at any point the elasticity is the same. It has nothing to do with the price. Okay? So it's constant. Not like the linear case, where in the linear case the elasticity strongly depend on the pi. Where are you here? So, they did the same thing, okay? And epsilon equals minus 2 everywhere along the demand curve, everywhere there. So before we go, we move to revenue elasticity of demand, that is about the consideration of the seller. I jumped over a few slides before, so I may go through this, but first I want to make sure, because it's not very clear in my opinion on the slides. So let me use the whiteboard to try to make the point. So the point is this: not all the time you have the demand function, or you know the demand function, but sometimes you know it at several points. So let's say that I have, this is P, and this is Q, and let's say this is the demand, and I know what is at these 2 points, okay? Sometimes if they are too far away, whatever I'm telling you is not very relevant. But if they are quite close to each other, not very close, but quite close, so let's say I have these 2 points. So this is actually P double prime, and this is P prime, and this is Q double prime that associates with P double prime, and this is Q prime. So typically, what do I do in order to find the elasticity at what point? Because remember, the elasticity, the point of elasticity of demand, where I do it point by point when I know the demand, just to remind you, was delta x, or delta q, let me call it delta x, delta p times p over q. And this, when the change in percentage term is very, very small, per unit change, but when I move on the price, very little, but I do it as per unit change, then this is actually dx to dp, or dq to dp. X and q, sometimes we use x, sometimes we use q, it's the same. Okay, the problem is, what is this p and q? And by the way, let me write p and x in this case. So actually what we do, we look at a point x, and in general, if I have this one, I'm looking at, this is x, this is p, and I want to find out the elasticity at this point. So at this point, so let's say this is 5 and this is 10. At the price of 10, we buy 5, according to this demand function. So in that case, what I have to do, I have to look on the derivative of the x with respect to p, and multiply it by p over x by 10 over 5. That will be the point, so let me write it better, at elasticity of xp, at the point where x equals 5 is, or if you want to put it on the p, it's the same, when the price is 10, it is dx to dp at this point where p is 10. So I take the derivative of the demand function, plug in, instead of p, 10, and multiply it by p over x, in this case 10 over 5, which is 2. So there is no problem on that. We saw an example, okay? 2 examples, actually 3 examples. But when I don't have the demand function, I cannot take derivative here. What do I do? So actually, I remember that the elasticity of demand is delta x over x, dividing by delta p over p. So at a point, a specific point, x and p, specific point x and p, I take the change in x divided by the x. That will, if you want a percentage term, I should multiply by 100 each one of them. So that will be the percentage change of x dividing by the percentage change of p. So I get it by the percentage change in x per 1 unit of change in the price of p. But I have to be relative to the point that I took, that I start with. But here I don't have a point. I have 2 points. I don't have the derivative because I don't know what is this and what is this. Maybe I know this part also, not necessarily. I have 2 points quite close together. What do I do? So actually, we approximate x and p by the average of this, by the average of x and average of p. What does it mean? I take the middle point. You see, this works better. So let me call the middle point p triple prime, which is p triple prime equals p prime plus p double prime divided by 2. Just the middle average of these two. And similarly, if I put, let me change it to be consistent with the x here. So if this is the x, and this is x double prime, and this is x prime, then I'll take this point to be x, this will be x triple prime, and x triple prime will be x prime plus x double prime over 2. So what will be, how do I approximate? So I have, this is the new x, I approximate it, but I don't go here because I'm not sure what is it even. So I just can say that my reference point is the middle point of the p's, the middle point of the x. And what I write is, what is delta x? Delta x, when I start with x prime, then the price went up, so I went down, so it should be delta x is actually x prime minus x double prime minus x prime. And delta p is p double prime minus p prime. This is positive, this is negative, because when the price goes up, quantity demanded going down. Fine, so now I have to divide this by x, or if you like, I should multiply by p over x, or let me do it slowly. So then I have, so delta, sorry, I'll try a better one, let's see if it works. Delta x over, I take x triple prime. Why? Because I take the average of this. So divided by delta p. What is the divided by delta p? divided by P triple. That will be an approximation of the elasticity of demand. But then this is what? Delta x is this. So I have x double prime minus x prime divided by x triple divided by p double prime minus p prime divided by p triple prime. Or if you like, you can write it x double prime minus x prime divided by p double prime minus p prime, and this goes up times p triple over x triple. That is the approximate, and this is I would say approximately. And this is called arc. Let me go now back. Before I go back. So sometimes you can call this distance half of the distance h and h, and then you can show that if h is very close going to 0, it approaches actually the derivative of x at the point, because when they go, h goes to 0, they go into the middle point. So you get exactly the middle point, and we can use this formula for the middle point is exactly the usual point elasticity. So let me just go back to do it, and then I'll show you